But then we should learn something like this as well. So these equations that look like these. So earlier on we had this, and how to simply solve the equations by Excel. Anyway, so earlier on we had only X and Y, and then you had something like this in the exam as well. Yeah, you solved it, and then you have also drawn the lines. Yes, there. So now something like this. So there's one variable more. So now, of course, you can still use the same. I have to take the 2 out. Anyhow, here you need 3 equations, and then you have 3 variables. Okay? And then, of course, you can use the same methods to solve. Hello. But it might be like really, really complicated, yes? If you start to solve this by pen and paper. So we would now learn how to solve these with Excel. I think this is the presentation for that. Yes. Okay. But here's quite a lot of new stuff. So we go through it a little bit, and then just to the main topic, solving systems of equations using the matrix method. Are you familiar with something like Matrix, or just the movie, or not even the movie because you're so young? That's also some movie of the boomer generation, yeah. Merely. Then, so a matrix is this kind of array of numbers arranged in rows and columns. So this is how it would look like. There would be, for example, a matrix A. And this is something that where you can organize some numbers. Of course, that means something, and usually you also want to solve something. This is for sure something that's been used in the computational methods, also maybe in the modeling programs many times. This would be 2 times 3 matrix because there is 2 rows and 3 columns. So there are elements, but we don't have to learn the matrices now that well, or maybe you can just watch the movie. That's very funny. But just to use something that's actually quite simple to use in Excel. So you would, well, anyhow, this is, you have each element there, and there's 2 rows and whatever 3 columns, and then you can like express it like this and whatever, but we're not here to learn about the matrices a lot more now. But there's, different types of matrices. 0 matrix, all elements are 0. What do you do with something like that? Whatever. That would be like having a normal 0 in normal calculations, yeah? Okay. You can add and subtract, or And then you would always add the ones that are on the same place. Or then you can also multiply. Here, for example, is just an example. If here would be this matrix A, and you would have multiplied it with 3, you would have just multiplied all the numbers in there by 3. Yes. Okay. And then if you multiply one matrix with the other, you multiply rows with columns and inner dimensions must match, but we don't do this now. You can also flip rows and columns. You can do many things for sure. And this is something that maybe you will learn if you need to learn about in some other course where you actually use some kind of application of this. Okay. Then there is this determinant called determinant, where you can just calculate a number for square matrices. And then you also have this kind of an inverse matrix. The matrix I, was it here, the identity matrix? Yeah, identity matrix is the I, whatever. It's something. Anyhow. Now, this is what we are aiming to do. So we are aiming to calculate the system of equations with this and solve a system of equations in Excel by using those matrices. So if you would put this into a matrix form, you'd write these numbers that are here multiplying X and Y, and you would just write them here like this. So you would have matrix A with those numbers, and then you would have this matrix X. You can also write it like this, and this would just mean that the first equation was so that you multiplied with this the X and with this the Y, and then this was here would be then the answers. And to solve this, you could, what was the expression in English for that? Inverse matrix, yes. So you can just dissolve the X from here, this X, you would only need to multiply with the inverse matrix, this B, these solutions here. And this is what we are aiming to. Okay. Okay, yeah, he was a bit more theory about the inverse matrix. You need to have a square matrix. So it says that you have both the rows, what were they called? It's a bit like rows and columns, the same number of rows and columns. It's almost like your name, yeah? Column. Okay. So the yes. And then if you do multiply matrix A with the inverse, you get this identity matrix that you would, in normal calculations, would be like 1. Yes. So if you multiply a number with an inverse number, what was it in English, the inverse number? Yes, then you would get 1. Yes, as a result. Okay. So this is something that similar thing that, but just with these matrices, and the matrix was this kind of, you know, with a lot of something with a lot of numbers. Yes. Okay. So if an inverse exists, an inverse exists only if the determinant, you don't even know what is a determinant. it doesn't matter. You don't have to decide if there is a determinant or no determinant, but this is something that you might hear later on in some instance, in some application, you might have to know more about this, but I don't actually know, because it somehow it appears suddenly somewhere just out of the blue. You have to know the determinant, but I don't know if in your applications that will happen. Okay. Because we don't, for example, do the vectors on these courses, but you might be doing those, and then you go more to this theory or way of handling mathematical expressions, basically. But this then, as you see, we would need to have this kind of inverse matrix. So if we have this kind of a simple matrix, matrix A, and this was to solve this kind of simple equations that we have learned to solve on paper, pen and paper as well. And we would write it like this. And then we would want to solve it with this method. And then already if we would start to do it on paper, this starts to look a bit messy. So we don't really save time. This is to, basically to save time. If we do this with pen and paper, and we would learn to do it not the way that we did it, but with this matrix method, we wouldn't really save time. Or maybe we could already make plenty of mistakes as well. So we would first have to compute the determinant. Definitely this one is in your technical formulas as well, and you can easily find it, and many things connected to this determinant. And then we would need to do something here, swap and change signs and multiply and, learn all sorts of tricks. I have also done this kind of a course early on when I was in technical studies in the university. That was called matrix algebra. And we were just learning to do these operations of the matrices, and it was actually super easy course, because you just did something very mechanical, but you didn't have to actually think anything. You just followed some rules. But you can easily also make mistakes here, and then, okay, so for example, this kind of a matrix, you would calculate the determinant. It's just an equation that you use. And then after that, you make the inverse matrix. And after this, you would be able to, why would I want the inverse matrix was to solve the X. So then I could multiply with the inverse matrix the answers, and I would finally solve have the solutions for X and Y. Yes, that I can do actually maybe even more simple, just in the way that we already learned. So then if I would have some inverse matrix 3 times 3, like that would be on with those equations that we want to solve now, then this starts to get really messy. So then you start to get the determinant, and then whatever, I don't even remember these things anymore at all. And then you can also make some kind of a shortcut. For sure, I've learned this many years ago as well. And you can get an inverse matrix by multiplying with identity matrix. And this was this is actually the identity matrix that would be like 1 in normal calculations. Just small, whatever. Many tricks you can do. And here is the example, for example. Okay, yeah, this is the one that's been now we got this matrix here, and now we want to solve this equation. So then we would need to do, using the matrix rules, we would need to multiply with this, and then we would get the result. Okay. But we don't want to do that now. We don't want to learn to calculate anything more with pen and paper because we already know how to solve simple equations with pen and paper. Okay, so we want to solve these equations that looked a bit different. So they were, I don't know where I have them. So these ones, yes, these ones we want to solve now. We know already how to solve something like this. And you already did it in the exam and you already know what it also means, the solution of these. And we don't need another way of doing that with pen and paper. So let's do it with Excel. In Excel is actually super easy. But first, we maybe need to also know what do these expressions mean. So we are now, if we have X, Y, and Z, we are in 3D space. And every point is defined by 3 coordinates, of course. And you can name the axes the way you want, but you know what it means, the spatial coordinates. So X could be horizontal, Y could be depth, not depth. And Z could be vertical. And all axes meet at the origin. And together they form the 3D coordinate system. Yes. And each equation, something marked with these X, Y, and Z multiplied with something or not multiplied at all. And here another number, it represents a plane in 3D space. Okay. So you would have this, and this. Sorry, there's no brackets here, but there should be. Each plane is an infinite flat surface. So it's a plane. Okay. And 2 planes intersect in a line. Okay, if you would have only brackets with 2 of these, but 3 planes generally intersect at 1 point. So we are actually wanting to solve an intersection point of 3 planes. Yes. This looks a bit, I got this from the AI, this looks a bit messy, but at least you can see some planes here and a point. I don't know if this is a great picture. Planes and a point, and that they would intersect at 1 point. This doesn't really look like it, does it? Well, whatever. So 3D coordinates describe positions using, yes, these coordinates. Each linear equation represents a plane. And this is definitely, this is the method for linear equations. If you would have some powers here with this, then this X, Y, or Z, then you couldn't solve it this way anymore. Intersection of 3 planes corresponds to the common solution, and in this case, but whatever. Okay, so here is an example. Yeah, and this is done with this Excel. Yes. Okay, so now we come to this. We have 3 equations. Then we make the matrix form. Then we don't check anything. We just compute the inverse. Obviously they done it, the AI did it just quickly with all those whatever methods. For sure it used Excel. And then we solve these X, Y, and Z. And we don't have to do it like this. We just get the result from the Excel. Doesn't that sound good? Sounds good. So in Excel, it would look just this simple. And you need only 2 commands. I think this was, okay, yes, whatever. Let's do this now. What was I planning to write something still? Let's see. Maybe we need to Yes. We can write something as well, a bit. Why not? Yeah, I could do this here. No, it doesn't look great. I put it here. Yes. That looks okay. Then I can take the Excel here as well. Maybe I want to write something first. Oops. Okay. So the equation that we need to solve is this is like the method of solving linear equations. With Excel using matrix. Matrices, for example, like this, we can write. Can I put it back? Wow. So we have an example. And it was this, whatever, it can be whatever. But now it would be x plus y plus z is 0. Did it look like that? Let's go. I think it was. No, it looks something different. Whatever, it can be whatever. Let's do this. Shouldn't we do this that is here? Yes. Let's not do anything else. Why do I have something else there? I don't know. 2x plus y minus z is 8. And then it would be minus 3x minus y plus 2x is minus 11. Minus 2x plus y plus 2z is minus 3. And this is something, I don't know what you use the systems of equations for, but this is something that is taught to you because of some other application on some other course. I don't know what that will be. But this is also something because usually the Ville, do you know Ville Salmi? Maybe you didn't meet him. Yeah, but he usually teaches the maths to the mechanical engineering students. He also teaches this. So this is for some of your application. Okay, so then let's write it in matrix form, just like it's there, matrix form. And matrix, this is now my matrix A. And I just put those numbers here. Okay, I took too many. Okay, it doesn't matter. So there would be 2, 1, minus 1. I just pick those, how do you say? What the numbers that those letters are multiplied with. So here it would be 2, 1, and -1. And then -3, -1, and 2. And then -2, 1, and 2. And this is my matrix A. And then I put here those letters. So here is X, Y, and Z. And this means if I would get it back to the equation form, that I would just, with this, I would multiply this. With this, I would multiply this. And with this, I would multiply this. This is if I would learn the rules how to calculate matrices. Who has actually calculated matrices before? You have. So for you, this is already familiar what I'm talking about. You don't remember. Yeah, I don't remember this either, but this is just something that we learn how to do this with Excel. There's many rules, and then if you would do this kind of a course and you would be doing like exam on paper, you would have all the rules there, and then you would just do it and then calculate it, and it's pretty simple stuff. But I don't remember that either. And then, so this was the A, and this was the X. Well, it's now I'm marking it with X. Maybe it could be better to mark it with something else because I already have X here. But it's just, and then here is what it is. So here is the solutions 8, -11, and -3. And what I knew was that I know certain things. So I know that A times X is B. This is B. No, this is my B. And then when I multiply it with the inverse matrix, here I get, this is like so little of the matrix theory, as little as we can have, is A -1 times B. Okay, so I want to, like in the normal calculations, I want to have here X alone. I'm just solving the X now here, like I would normally do. And this, I would get the whatever identity matrix that would be the same as 1 in normal calculations, yes? So then I get here only I times X, which is only X. And here the A -1 times B. So X is A -1 times B. And this, if I would just do it on paper, it would be something I can, well, this is exactly, I'm just writing it there. So then somehow I got this A -1. So I have here the matrix X, which means matrix X was X, Y, Z is, and then here I have the, well, I just write it like this. 2, 1, -, -1, 2, and -2, 1, 2. And I have to take this, I have to take the inverse matrix. I still didn't. And here I have those answers. That would be 8, -11, and -3. This is how it would be with these examples. So this was the matrix X. This was the, well, I have to still take the A -1 from this is still the A. I don't have the, I have to do the -1 operation. That obviously, at least in the paper, was pretty difficult, or not difficult, but you have some work to do. And then finally, I would have got it. And let's see here. So I was solving this same thing, wasn't I, here as well? Yes. So I got the a minus 1. So here again, I have this x, y, z. And here now I have the a minus 1, which was 4, 3, minus 1, minus 2, minus 2, 1, and 5, 4, and minus 1. And then with this, I would need to multiply now this 8 minus 11 and minus 3. And I would get then those solutions x, y, z would be 2, 3, and minus 1. Okay, I can mark it like this. And now we do this with Excel. Yes. So here's my Excel. I think I already did it here. I try to copy this. For example, so I write here my matrix A. I already did some, but I write it again. Yes? On the paper?
X comes 4, 3, negative 1.
X comes.
Yeah, so that's part of or yeah,
Yeah. You don't need to understand it. There's no need to understand it. So here is the X. Again, this was the X. So this is now the A minus 1. It was in the way of that was complicated. This is the complicated part. So getting from this to this is the complicated part.
Then how would I do that?
Yes. Now we just do it with Excel. This with Excel. If you do it by hand, it's complicated, but of course you can do it by hand.
Inverse.
You mean here? Okay. So here, if you want to have the X alone, if you're solving something, for example, like you do normal equation solving as well, you want to solve an X. So if you would have A times X, here, of course, you can we would normally say that we divide it here. What would it be normally so that we would say, I'll just put it in brackets here, that we would divide it with A, yes? But you can also solve it so that you it's exactly the same thing with normal numbers, that if you divide it with A or if you multiply it with the inverse of A. Because the inverse is the inverse of A in normal numbers would be 1 divided by A. So if you now multiply with 1 divided by A, you get here 1, yes? And in matrix operations, we have to do something like this. So in matrix world, you do something, you don't divide a matrix with matrix, but you multiply with the inverse of the matrix. And this is maybe something that you will learn at some course more thoroughly. Here, we won't do it. More than we just somehow I try to tell you why we do something like this, so that you would somehow a bit So then if I multiply it with the inverse of A, I would get this identity matrix would be, which in matrix world is the same as the number 1 with the normal. So if you multiply something with 1, you can multiply anything with 1 or divide anything with 1, but it's still the same, yes? But then I get, of course, if I multiply it, I multiply the both sides. And so then I also multiplied it here, and now I have the inverse matrix of A times B here. And the B, my B was the solution matrix of the solutions. Yes. Okay. So now we go to the Excel to do this thing. So I write here the A, like I did earlier. Now you should all have Excel. And you could try to do this, and then you can try. Do you have computers? X, Y, Z. Do you all have Excel? So now I write here, well, okay, I don't have to write it anymore. You can write it. So here I have those numbers that I had there. I could also write them. I just do it like this. So they are here. Those are numbers that I multiply. So here is the numbers that I have multiplied X, yes. Numbers that I multiplied Y in those equations, and numbers that I multiplied Z in those equations earlier. So that's my matrix A. Then it was the B that were the solutions of those equations, solutions. So here would be 8 minus 11 and minus 3. Now I don't do the complicated thing, but I do the A minus 1 matrix. And I don't know if this is actually compulsory anymore, but maybe I have to have the space for it first. So I have to mark how big it's gonna be. At least earlier it was like this, that to get this from the Excel, you have to mark the space. And then I put the command from the Excel. So I just write the function there. It's the minverse. So minverse means matrix inverse. And then I have to pick it. So I pick it. And now I have to put there of which numbers I want the inverse. And then I mark the numbers that I want the inverse from. And then it tells you in Excel what you need to do basically. And then I just press enter. And it gives me the matrix. So this is pretty simple, yeah? I don't have to do the complicated whatever determinant and whatever swapping numbers and multiplying them and whatever things at all. I just do it like this, yes? And then next I get the answers here. So what will my X, Y, and Z be? And again, I need a command, which would be M. Again, I'm with the matrices, so I first put the M, and then I need to multiply. So it's the M mult, which means that I'm multiplying a matrix. Mult. And I take it. I take on. Yes. And now I have to know what I multiply with what. So I multiply this, the inverse, and now somehow it doesn't, something went wrong. I'll try again because I don't know why it did like that. Yes, maybe it's fine. Why does it mark it like that? I don't know. And then I multiply these solutions, yes? I hope this goes well. Ah, maybe I should have marked first that it has to be 3. Let's see what happens. Yeah, it did it fine. Okay, so I didn't even have to mark here that it was supposed to be this big. And now I get the solutions from there. Okay, so you didn't get those at all. Yes. But then, yes, just like that. Wow. And do you have the same, are these exactly the same results for 2? Yes, because this is, you don't have -3 there. This is a different sign. So you, of course, then your solutions, your inverse is different. The solutions are different. Everything's different, you know.
It would be better to make them later.
No, we won't. We won't. We will just do this now as something that's a bit different. And then we are done with that, and then we continue. And this is for some applications later. I hope you will use this there. Yes. Otherwise, this doesn't make much sense that we did it here. But like, you know, to solve, because earlier on this course, there were maybe some more complicated exercises to solve by hand. And then it doesn't make any sense. You just start making mistakes. So immediately you should use Excel if you need anything more complicated to be solved, because you have it always as a tool. Okay, so now our task only on this class is to calculate those exercises that are there. So I sort of try to explain what we are gonna do, just using matrix as a tool, as a like to help us, and then solve these ones. So here also you can, it says solve, choose yourself how, but don't solve by hand, to solve by Excel. Yes. So because if you start to do something, because I think we had already on this course something like this to be solved by hand, but it doesn't make any sense. Then of course you need different kind of a method, but if you're on some course, you will get to the situations where you have something like this, and then you have the powers somewhere. For sure on that course, they will teach you how to solve that. But if you have something like this, then you know how to solve it with the Excel. Okay, so now just train these, do this with the Excel. And that's it. Then we can move on. Oops, what did I do? Yeah, take it.
Wait, on sheet 1.
Okay.
Like the.
You mean this?
Oh, no,
This is some other that I did.
Yeah. They would. Yeah, these ones here, they like say they fall apart.
How did I get them?
Yeah.
Yes. So here I need to put, let's see what it says. What? Why can't am I doing something weird now? Hmm. Okay, so it's this M mult. So it's matrix multiplication, and then you just mark this one, and then you mark the solutions. So let's go again this. Here you can see. So you would pick the this. So you write M. First you write this is when you are picking a function from the Excel. But you've been doing this maybe in the physics. Yes. Then you want to know which one. So it's M, which is matrix, and then mult. And then you pick this. And then it tells you already that you need 2 arrays there. Yes. So first you have to pick the array 1. And here it would be the, oops. Now I have, there's something weird going on with my, okay, whatever. Come on, do it. Is it because I put it this small? Let's try like this. And try again. Yeah, it didn't work like that. Okay. Doesn't matter. This is my first array, and then I have to put this in between because it tells me, what is this called in English? Semicolon. It's almost like your name again, but semi. Okay. And then very funny, yeah. And then the next that I multiply. And then I have to close the bracket. And then I just press X. Oops. Now I didn't get it. Ooh, what did I do? I'll try again. Now it's still, yeah, I did one too many. I wasn't, so let's, like that. It won't give it because it can't multiply something that looks like this with something that has 4. It would be impossible matrix operation. So now I got it. Did you manage? Yes. So this is pretty simple, yeah? Excel is a great tool. We don't have to, you don't have to take the course that I did with the matrix algebra and learn all those methods by hand, like. So I'll try to do now the other exercises. Now it just didn't want to be like this here, like a small Excel. I just put these exercises. Oh wow! Let's see if this works. Okay. So how did I write it? It was A. Matrix A. Yeah. And then I know that is X, Y, and Z. And then it was the B. That was the solutions. And here I put the numbers. So I would have 2, 3. Oh, why don't I? Yes. Okay, 1. The solution is 11. I can already write it like this. 1, 1, 1, and solution is 6. Of course, then I also have to know that those equations are in the same form so that it's always, oh, here it has to be, yeah, there's one mistake or whatever. 3, 2, minus 2, and 1. And then I had to write the inverse. So now I take the inverse. Oops, I'll write it like this. A minus 1. Okay, and it would be here. M inverse. I take the inverse. And then I just put one array here. Just like that. Okay, now this is something horrible. If I would have to calculate this by hand, it doesn't look nice. And then, what did I do next? I just get the solutions, yes. So then again, I write what are the solutions. So now I get here the x. Come on. X, Y, and Z with the multiplication. This shows me in a weird way. Mult. Which would be, oops, no. Like this. What? Try again. I need to put this big because it doesn't want somehow. It's very weird. Mult. This. And this. Haha. How simple is this? I can also try to solve, for example, one of those like very simple ones like this. Do you manage? Yeah, you don't know because I wonder if I could solve something like this with GeoGebra, something in 3 dimensions. Try 3 dimensions. Would it show it correctly? I'll try the one that was really simple. Oops. No. Yes. The one that I sort of one of these, for example, the 1A. As an example here. 1A. So I would write here, let's do it like this. No. Okay. A. So I only have X and Y. Y. I have 1 minus 2. And then I have minus 6, that's the solution. 7, 3, and 26. And this was the B, that would be solutions. B, solutions. Then I want the inverse. A minus 1. Inverse. From this. Wow. And then I want to get the X and Y. X and Y. S. M mult. And I want to multiply this with this. Let's see what I get. Oops. This was our first calculation here. This is something that you can also easily draw with GeoGebra. Maybe there is a 3D GeoGebra as well, that where you can put this kind of planes and their intersection point. I don't know where you use this in your applications. I don't know at all. For sure, I've used something. I've calculated systems of equations in some applications when I was in the engineering. But I don't remember. That was a long time ago. But I remember using them. I was like, okay, now I've learned this and now I'm using this. This is actually nice. But, you know, not since then, no. And some circuits, you with electrical circuits, for example, there you need to calculate many things, you would need to use systems of equations, but I don't know how much you will be doing electrical circuits in mechanical engineering. I don't know about that. But I'm not gonna put any application from physics to this, because I didn't do that even in the physics when I had that topic, because I didn't know if anybody would be able to calculate those things. You know, I started to feel a bit too complicated. And for sure, if you are using it in practice, you have some kind of a computational program that uses some kind of logic like this behind there when you calculate some circuits. But for sure, if you're learning about this, you would need to do it yourself. These equations, basically just solve them. Yes. Okay, I'll try another from here. But how simple is this? Yes. Okay, so which one was this? This was what, like I calculated the 6A. 6A. A. And I would need the A minus 1, which would be then I would get the solutions X, Y, Z. And how can I check if this was correct? Well, I don't know if it makes even any sense, any difference, because we're not really calculating anything. At least we know as long as these are correct, so there is no problems with those. For example, here's a minus if there needs to be a minus, then you get those correct solutions here, because of course with Excel you can trust. In Excel you can trust, but maybe yourself. When you're calculating with pen and paper, you never know. Yes. So here you can, if you have now this in Excel, then you already know now that if you need to calculate something like this, now you know the commands, yes? You can find them from here, what you've done. So even if you did it only once or twice, or you see that this is pretty simple. So this was one sideline of the of this course. Anything like this you can, and then now we get always the solutions. I think these ones, where did I take these? Well, they were from somewhere, but they were planned so that you get this kind of answers with what is this number called now? Like wow, I don't remember what is it in English when it doesn't have any decimals. Whole number. Yeah, it must be something different, maybe. But of course, you can get any answers when you are calculating them in your applications. Most probably they don't look this nice. Yes. Okay. So then if you're happy with this, now maybe we can do like, or you can do because we did this. So if you want to do one more calculation of, this is something with the physics that I put here, but I don't know if this gets a bit too messy again, because it's there's these equations and whatever. You can think about it if you want, because there's also the solution, or then just the calculation 5, just to form this kind of a system, and maybe even try to solve it then with the Excel. Yes, if it's solvable with Excel. Mm. 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 So it's pretty it's also easy otherwise, but it's also pretty easy with Excel, yes. Do you have some kind of exam with Jaakko then? Or do you just have the exercises? Only exercises. Yes. In the end. Yes. And do you use for sure Excel there? Yes. But we don't use Excel in the exam. Because we are here to learn so like simple things. Yeah. We're not gonna do this in exam. This is just a sidetrack. For some other courses you will have later on where you should need this kind of techniques. So here we could have, of course, solved something and put it somewhere, which is super easy. Like it's so in the, for example, what did I want to solve? I wanted to solve the raisins, that was X. So if I solve here the Y, $500 minus X. And then I put it there to the other equation. Yeah. So I have the Y now from this and I put it there. So I get then Y appeared there that I just solved. And then I would need to calculate this. multiplied this multiplied. Okay. So I would maybe need a calculator here.
Why is like, yeah.
Why is, yeah, because I solved it. So this was the simple equation. And then from there I would solve the y.
45.5.
Oh,
That's the final answer.
yeah, I don't yet, I'm calculating this now by hand.
Yeah.
The same thing. So then here I need to multiply with this, both of these things. So of course I get here like 5.4x minus 5.4x because there's a minus sign. If I would want to do, so I just hop there. But then if I do 5.4 times 500, yes. I didn't calculate it in my head, but just with the calculator. And this would be 2, 5, 14. And then I just solve this with the normal methods. So 2.9 minus 5.3x. Well, I can calculate it with this as well. I get minus 2.5x from these two. And then I need to get rid of this, yes. So I have taken out the minus is this 2, 5, 14 minus 2. Yes. And here again, maybe I want to use the calculator. (2.5x) is minus 186, and then minus, and then I have to divide with the minus 2.5. I don't know if I need to put the brackets here. And I get the same answer here as well. And then, of course, if I have, this was the raisin, so that was 74.4 grams. So then the nut is, of course, the totally I had 500 grams. So then this would be 500 minus the one that I got. To 5.6. And it looks exactly the same as in my Excel. So this wasn't very difficult. Something like this is, of course, not very difficult to calculate with pen and paper either. But maybe this was a bit faster. Yeah. Excel is a good tool. The 4. Oh, that one, yes. Yeah, this is a bit this is messy. We don't have to do this. But here this would be the what is it called in English? Density. Yeah, this is actually not P, it's raw. Yes. Raw. It's a Latin. Yes. So I realized we have been having this kind of an exercise in the architect students exam actually. And then I realized when somebody calculated this with this system of equations, oh yeah, you can do it like this as well. This is very clever. So then I thought that maybe it could be used here as well. Well, okay. But maybe if you would have been doing this already in the physics, maybe it gets a bit too messy if we start doing it here and then we again need some new information from the physics if you didn't go through this topic there yet. But maybe if you calculate this kind of calculations at some point in the physics, you can see that how it can be done as well with the system of equations, because it was really difficult to find anything. Well, then maybe with the electrical circuits. But I'm not that familiar with that topic myself either, with calculating like the electrical circuits, just the basics. Well, of course, something else as well, but it's not like I've been teaching it a lot. So it would take quite a lot of work for me to work out some kind of example from there that I could explain it to you so that you would also understand it without the theory behind that maybe it's not that simple. Why are we calculating this with system of equations? Well, but there's a lot of physics already that maybe you need to know.
It's nice that like you've got the bracket with the it looks very similar to like programming stuff. I've never done it.
Yeah.
But yeah, I can see where it be useful. That makes sense. Like
Yeah. Maybe you will be using some, and for sure these like matrix can be used easily in the programming as well. You have, and it realizes what you mean. You just put the numbers there and then it calculates something for you. For sure there's many applications. Well, at least now you sort of know what is a matrix, if you didn't hear before. Okay, thank you. Let's go and have lunch. And next topic will be the something very simple, just the powers and the square roots and only their rules and nothing more. No applications, I think.